Hello, okay, let's try this again. Thanks for your patience with me resending this. This isn't the format that my computer takes it best in. I do have a Mac, so it does use Pages. However, converted to a PowerPoint, I hope that it still is smooth as I present. So I chose to do tannic acid. The reason I chose to do this topic is because I, as well as many other people, have mistaken tannic acid for something that is in wine. I thought it would be similar to those of tannins. However, there are two different things which we will talk about shortly. Here is the structure of tannic acid. We have both the 2D and the three-dimensional pictures, the three-dimensional being underneath. For the chemical properties, the melting point is 218 degrees Celsius. Tannic acid has a boiling point of 862.8 degrees Celsius. It is soluble, and it has a yellow to brown color. Its form is powder or solid. It is air and light sensitive. Tannic acid is stable, but is incompatible with metallic salts, strong oxidizing agents, iron, and heavy metals. Chemical properties continued. Tannic acid contains no carboxyl groups, but is weakly acidic because of the multiplicity of the phenolic hydroxyls. The hydroxyls also cause it to be extremely soluble in water. All regulatory authorities classify it as non-hazardous substance. So these are the uses of tannic acid. It's kind of the uses as well as the history. In 1985, the U.S. Food and Drug Administration listed tannic acid as, quote, a generally recognized as safe product. That means that it is not harmful or dangerous, but we will learn later that that's actually not true. Tannic acid can be used in pharmaceutical, cosmetic preparation as the ingredients, and it is used as the ingredients in foods such as frozen dairy products, meat products, or drinks such as soft drinks, tea, and wine ingredients. Tannic acid can inhibit the growth of bacteria and the intestinal absorption of toxins. It can be used for tanning, fishing net dyeing, boiler cleaning, drilling, and other uses, predominantly in medicine, food, pesticides, and antibacterials. Tannic acid's application. As the name implies, tannins are used in leather tanning. Other commercial uses are in dyeing, ink manufacture, paper sizing, food and wine processing, and the production of gallic acid. Historically, tannic acid was used along with activated charcoal and magnesium oxide as a universal antidote. This is interesting to me because, as a side note, I know of many people that will take charcoal pills for toxin, and I have seen ones that list tannic acid. So it was cool to learn that although it was formerly used for poisoning, the three ingredients in combination were believed to work better at absorbing than any other ingredients alone, but unfortunately that was not the case. The activated charcoal soaked up the tannic acid, making it less inactive. This made the combination less effective. Also in tannic acid, it's in foods and beverages. Tannic acid is used for a flavoring agent. Physical characteristics. Tannin is presented in the bark and fruit of a variety of trees such as oak and sumac. And in order to extract the tannic acid, one would have to go into the tree where there are insects, remove the insects and the droppings and other impurities, put into the copper or wood extraction tank, and extract with soft water. The extract was concentrated under reduced pressure, and then you add a small amount of ether, apply spray drying so that the light tannin is obtained. When it comes to a medicinal use, tannic acid is produced through extracting the concentrated solution with ether, with the extract being bleached by sodium bisulfate and further recovery of ether to obtain the final medicine tannin. When wine is kept, so this goes back to what I thought would be more tannic acid, but when wine is kept in oak kegs, some tannic acid will migrate into the wine. High levels of tannic acid are found in some plant galls. These are formed by plants, as we just mentioned, but that are infected by certain insects. And those certain insects pierce the plant leaves, and when the egg hatches out into the larva, the plant produces a gall which surrounds the larva. So while tannic acid is a special type of tannin, plant polyphenol, the two terms are sometimes incorrectly used interchangeably. The long-standing misuse of this term and its inclusion in scholarly articles has compounded this confusion. This is particularly widespread in relation to green tea, black tea, and both of which contain tannin but not tannic acid. Although it is said that tannic acid is used in pesticides, medications, and food, as we mentioned earlier, and also that it was not unhealthy, we see here differently. Tannic acid could cause potential health hazards, such as damage to the eye, skin, respiratory tract, and gastrointestinal tract. It may cause irritation, redness, pain, blurred vision, and possible eye damage. When tannic acid is absorbed through the skin in harmful amounts, which, as we know, it would be if it were used in the production of makeup, as mentioned earlier, it can cause irritation, redness, and pain. Nausea, vomiting, and diarrhea are symptoms of tannic acid ingestion, and prolonged exposure may cause liver damage. Upon inhalation, tannic acid may cause respiratory tract irritation. And here we have my references. So from PubChem is where I found predominantly this structure, the chemical and physical reactions. The phytochemicals was where I found kind of the fun facts, the difference between tannins and tannic acid. And annin is where I found the rest of the information, the history and the uses. Thanks so much. Have a good day.